In this video, I'll be going over how to add decimals. The 3 steps for adding a decimal. Decimals needs to line up. Second step, 0 as a placeholder. Third, and the last step is to add. Here is an example. 55.21 plus 12.5. So we'll write this out as we will write it out like this: 55.21 and 12.5. To figure out where to place 12.5, we need to see where the decimal point is, and this is where decimals line up. In this case, the decimal point is right here. So before we write 12.5, we need to make sure that the decimal of 12.5 is also in the same position. So we'll write 12.5. Okay, now that we've lined up the decimals, our second step will be to place 0 as a placeholder. So in this case, this spot here is empty, so we need to place the 0 here. And finally, we can complete the addition process. Okay, so 1 plus 0 is 1, 2 plus 5 is 7, decimal point drops down, 5 plus 2 is 7, 5 plus 1 is 6, and our answer is 67.71. The most important part about this is this decimal point. We need to make sure the decimals are placed in the proper positions. Here is another example. 45.782 plus 121.22. Okay, so we're gonna go ahead and rewrite this and make sure the decimals line up. So we have 45.782. Then the second number, we want to make sure that the decimal point is here, and since it's 121, so it will be 121, and then we'll place the 22 after. And now we're gonna place 0 as placeholder here. And finally, we could add. So it will be 2 plus 0 is 2. 8 plus 2 is 10. So there's a plus 1 here. So 7 plus 2 plus 1 is 10 again. So another plus 1 on top. And 5 plus 1 is 6. Plus the 1 is 7. And make sure the decimal point is here. 4 plus 2 is 6. And we bring down the 1. And our answer is 167.002. What about this one? 7.7 plus 253.25. Okay, so we're gonna go ahead and line up the decimals. 7.7. In this question, we gotta be really careful because the decimal point needs to be here, and the number is a lot bigger, which is 253. So we gotta write 2, 5, 3, like so, and then 2, 5 after. Okay. So now we're going to place the 0 as a placeholder here. Then we're going to add them together. 0 plus 5 is 5. 7 plus 2 is 9. Decimal point here. 7 plus 3 is 10. 5 plus 1 is 6. And bring down the 6. And our final answer is 260.95. Here is another question. 0.62 plus 54.1. Again, we're going to line the decimal up. In this case, 0.62. And the second number, decimal point lining up here. We write 54 like so, and then we put the 1 behind the decimal point. Then we'll see that there's a placeholder. We need to put 0 here. Then we'll complete the addition process, taking 2 plus 0 equals 2. 6 plus 1 is 7. Bring the decimal point down here. 0 plus 4 is 4. Bring down to 5. And here we have it. The answer is 54.72. In this video, I'll be going over how to subtract decimals. The 3 steps to subtracting decimal include lining up the decimal, place 0 as a placeholder, then complete the subtraction process. Here is an example. 55.21 minus 12.5. So we'll write it like this, 55.21. The first step is to line up the decimal points. So we'll place the decimal point here. Then we're gonna have to place the right numbers in here. So in this case, we have 12.5. So we'll put 12 and then 5 here. Now the next step is to place 0 as a placeholder. And since we don't have anything here, so we'll place a 0 here as a placeholder. And finally, we'll complete the subtraction process. So we'll take 1 minus 0 equals 1. 2 minus 5, need to borrow 1 from the 5. So that'll be 12 minus 5 equals 7. Now this becomes 4. So 4 minus 2 is 2. Now the decimal point needs to be here. And 5 minus 1 is 4. And our final answer is 42.71. Here's another question. 121.22 minus 45.782. So we will rewrite it like this. 121.22. Then we need to line up the decimal. So decimal point here. Then we put 45 here. 782 here. Now there's an empty spot here. And we need to place a 0 as a placeholder. And now we can complete the subtraction process. So 0, need to borrow 1 here. This becomes 1. And that's 10 minus 2 equals 8. And now we have 1 minus 8, which we need to borrow another 1. And that becomes 11 minus 8, which is 3. And then the 1 needs to borrow 1 again. And that will become 11 minus 7 equals 4. Now we bring down the decimal point. And then we need to borrow 1 again here. Then we have 10 minus 5 equals 5. then we need to borrow 1 here, and that would be 11 minus 4, which is 7. And our final answer is 75.438. Here is another one. 253.25 minus 7.7. 7.7. Okay, so we'll rewrite this as 253.25, and then lining up the decimal point, 7.7 minus, and then place a 0 as a placeholder here, then subtract. So 5 minus 0 is 5, 2 minus 7 need to borrow 1, equals 5, bring the decimal point down, 2 minus 7 needs to borrow, 12 minus 7 is 5, bring the 4 down, bring the 2 down, and our answer is 245.55. And here's the next one, 54.1 minus 0.62. Okay, and we'll rewrite it as 54.1 lining up the decimal point, 0.62. Complete the subtraction. Place 0 as a placeholder here, then complete the subtraction. 0, borrow 1, 10 minus 2 is 8, borrow 1, 10 minus 6 is 4, bring the decimal point down, 3 minus 0 is 3, and bring down the 5. And our answer is 53.48. In this video, I'll be covering multiplying decimals. So here is an example. 5.7 times 5 equal. Here we're gonna go ahead and times 5 to the 7 just like before. So we're going up. 5 times 7 is 35, so we bring the 3 up. Then we have 5 times 5 is 25 plus equals 28. When we look at this, we'll see that there's one decimal point that we need to take account for. So from the answer, we also need to do the same. Bring that decimal here. So your final answer will become 28.5. Now the tricky part is the decimal point, so we need to make sure that the decimal point is done at the final step in order to get the answer correct. Now let's try another one. 4.5 times 6. Again, we take 6 times 5, 30, bring it up. 6 times 4, 24 plus 3 is 27. And then we have the one decimal point, which we need to do the same here, and we have 27.0 as the answer. Now let's try another question with two numbers that are both decimal times together. Here's an example. 5.5 times 7.8. So again, we're gonna take 8 times 5 equals 40. Okay, and then 8 times 5 is 40, so plus the 4 equals 44. 7 times 5, 35, put the 3 on top, and then 7 times 5 is 35, and then we add the 3, becomes 38. So we bring the numbers down 0. 4 plus 5 is 9. 4 plus 8 is 12. 3 plus 1 is 4. Now at the final step is where we put the decimal point. Now in this example, there's a total of 2 decimal points. So there's 1 here and 1 here. So at the final answer, we know that we need to add 2 decimal points. So we need to go 2 spaces to the left, 1, 2, and the decimal point will end up here. So the final answer of this will be 42.9. Now let's try another question with 2 numbers, both with decimal points. 8.2 times 9.5. 5 times 2 is 10. 5 times 8 is 40, plus 1, 41. 9 times 2 is 18. 9 times 8 is 72, plus 1, 73. Okay, we're bringing all this down. Again, we know there's a total of 2 decimal points that we need to take account for. So we move 2 spaces to the left, decimal point ending here. Answer 77.9. Now let's try a different questions, but we'll have one number that's to the 10th power and one number to the 100th. So the example would be 6.25 times 5.2. Okay, we're gonna take 2 times 5 is 10. 2 is 4 is 5. 2 times 6 is 12. 5 times 5 is 25. 5 times 2 is 10, so 12. 5 times 6 is 30, so 31. Bring it all down. And in here, we can see there's a total of 3 spaces that we need to take account for. And so we'll do it here, 1, 2, 3. So decimal point ended there. And the answer is 32.5. Now here is another example with 2 numbers, both at 100th decimal point. 10 times 2, 5 times 5 times 5, 2. So we'll take 2 times 5 is 10. 2 times 2 is 4 plus 1. 2 times 0, 0. 2 times 1 is 2. 5 times 5, 25. 5 times 2 is 10 plus a 2 is 12. 5 times 0 is 0. 1. 5 times 1 is 5. Now we'll go 5. 5, 5, 25. 5, 2 is 10 plus 2 is 12. 5 times 0 is 0 plus the 1. 5 times 1 is 5. Bring it all down. Now here we see there's total of 4 spaces, decimals. Now there are a total of 4 decimal spaces which we need to take account for. So we'll start 1, 2, 3, 4, ending the decimal point here. So our answer will be 56.58. In this video, I'll be talking about dividing a decimal by a decimal. 8.6 divided by 0.5. So the first thing to look at is the 0.5. We see that this is not a whole number. So when we write out the division, it's 8.6 divided by 0.5. When we have a divisor that's a decimal point, we need to make it into a whole number first. So we see that this decimal point need to move one spaces over. And when we move one decimal point from the divisor, we need to do the same here as well. So now let's rewrite the question. It will now become 86 divided by 5. Now we can solve this question by dividing, and it will be 1, that's 5, 36. 5 times 7 equals 35. Bring the 1 down, and the 86, we can add a 0 and bring it down here. And 5 times 2 is 10. So our answer to this question is 17.2. What about this one? 64.8 divided by 0.24. Now let's do the same way where we look at the divisor of 0.24. So we take 64.8 divided by 0.24. Now the divisor need to move 2 spaces over, and we need to do the same inside. When there's an extra space with no number, then we need to fill in a 0 because the decimal point is now here. So if we rewrite this question, it will become 6,480 divided by 24. Now we can solve this question with division. So this will be 2, 48, 16, bring down the 8, 7, 68, 0, and we bring down the 0, and the 0. So our final answer here is 270. Now let's try one where the divisor is to the thousandth decimal point. 24.6 divided by 0.048. So we will rewrite the question like this: 24.6 divided by 0.048. Now feel free to pause the video if you wanted to find out the answer first before the final answer is revealed. So here the divisor need to move 3 spaces and need to do the same here. 1, 2, 3, and the decimal point will end right here. Then we'll fill in the 2 zeros. Okay, and now if we rewrite this, 24,600 divided by 48. Now we can solve this question. That's 5, 240, 6, bring the 0 down, 1, 48, 12, bring the 0 down, 2, 6, 24. Now we can add more 0 in the back of it here and bring it down, and now this becomes 240 and 5. So the answer is 512.5. Now let's try one where the divisor is to the 10,000th point. So in this example, 6.4 divided by 2.1243. Now we want to round this to the 100th position. Okay, 6.4, 2.1243. So here we'll see that need to move 1, 2, 3, 4 spaces, and 1, 2, 3, 4 spaces. Decimal point ends here, and we'll fill in the zeros and rewrite this as 64,021,243. Now this is also a big number, so I'm going to use a calculator in this case, or else it will take a long time. So we'll put 3. 63,729, 271, 0, bring the 0 down, and decimal point here. Now this will be 0, and then we need to bring another 0 down. This will be 1. 5, 8, 5, 7. Another 0, bring it down. 2, 4, 2, 4, 6, 1, 6, 0, 8, 4. Now since we are rounding to the 100th position, we're looking at here. And since 2 is less than 5, so our final answer will be 3.01. And that's the final answer. In this video, I'll be going over how to divide decimals by whole number. Here is an example. The first thing we want to look for is the divisor. We can see that in this case, it's a whole number. So we'll write out a division like this. And the first number we compare is here, 6 divided by 5. We will take 1, so 5 times 1 equals 5. And we minus 6 to 5, we get 1. And then we bring down the 5 here. And there's a decimal point here to align with the decimal point here. So the next step we'll have 15 divided by 5. And we can see 3 will go into it. So 5 times 3 equals 15. And we minus, it becomes 0. Then we bring down the 5. So now we have 5 divided by 5. And that will be 1. And the remainder is 0. So this would be our final answer. And if you want to test and see if the answer is correct, you can always take the answer and times that by 5. And what we're trying to do is see if the answer will come out to be same as 6.55. So we take 5 times 1 is 5. 5 times 3 is 15. 5 times 1 plus 1 is 6. And so we can see that this number matches this number here. And that tells us that the answer of 1.31 here is correct. Here's another one. Again, we can see that the divisor is a whole number, and we'll write out division like so. Now in this case, we take 3 divided by 10. We can see that the 3 is too small, so we'll place a 0 right here with a decimal point to align, and then we'll skip over to 32 for the next space. So now we have 32 divided by 10. We can see 3 go into it. So now we have 32 minus 30 equals 2. Then we'll bring down the 5. Now 25 divided by 10, we have 2. So 2 times 10 is 20. After you minus 25 to 20 is 5. Then you bring another 0 here and carry it down. Now we have 50. And we'll take 50 divided by 10. That will be 5. So 10 times 5 is 50. And the remainder now is 0. And therefore, the answer is 0.325. Now, what about this one? So for this problem, we're going to go ahead again. We'll write out the division. And we'll compare the 6 to the 4. And 1 can go into it. 6 minus 4 is 2. Bring down the 3. 23 divided by 4. 5 goes into it. 3. And we bring down the 2. 32 divided by 4. We get 8. We bring down the 4. And 4 times 1 is 4. And that gives us the remainder 0. And our answer is 15.81. In this video, I'll be going over how to multiply whole numbers by decimals. The 2 steps to accomplish this is first is to multiply. Secondly, place the decimal point back into the answer. Here's an example. The first step is to multiply, so we'll write out the multiplication. When multiplying, we want to place the number in the proper position. So the first step is to take 6 times 8, and then 6 times 1, and the number that we want to place is aligned here. So 6 times 8 is 48. We'll place the plus 4 on top. 6 times 1 plus 4 is 10. So we'll place it like this. Now, the second one we want to handle is the number 2. And we want to place the number aligned here. So 2 times 8, 16. We'll place the plus 1 here. And then 2 times 1 is 2, and plus the 1 is 3. Lastly, the 0. And we want to align the number here. So 0 times 8 is 0. 0 times 1 is 0. And finally, we add them all up. So the 8 will bring it down. 0 plus 6, 6. 1 plus 3 plus 0 is 4, 0. And the last step is to place the decimal point in the answer. And the way to do that is to first locate where the decimal point is. The number 0.26 has 2 decimal spaces. So in the answer, we want to also place 2 decimal spaces. It would go like this. 1, 2. And the decimal point will be placed right here. So the answer would be 4.68. Here's another example. 8 times 7.36. So the first step is to multiply. So we'll write this out. 8 times 7.36. Now using the same process, we're gonna take 6 times the 8, align it here, so we have 48. Then the next one would be 3, and so 3 times 8, 24. The next 7, 7 times 8, 56. Now we add them up, bring down the 8. 4 plus 4 is 8. 2 plus 6 is 8. And then bring down the 5. And lastly, we need to find out the decimal point. So that's 2 spaces. So we're going to apply the 2 spaces here. And our final answer is 58.88. In this video, I'll be going over how to divide whole numbers by decimals. When dividing a whole number by decimals, we want to first check for the divisor, whether it's a decimal or whole number, and then we will use the power of 10 multiplication in order to complete the division. Here is an example. 425 divided by 0.5. So the first part, we're going to look at the divisor. You can see that the divisor is 0.5. So we'll write out like this. Now the second step is power of 10 multiplication. As we see here, the decimal point, since the divisor has a decimal point, we need to multiply it by power of 10. So when we multiply by power of 10, what we are doing is moving a space over. And when we do that for the divisor, we need to do the same here as well, inside. After we complete this portion, we're ready to divide. And now we will rewrite this as, and now we can complete a division. So 5 times 8 is 40. Subtract, we get 2. Bring down to 5. And 5 times 5 is 25. Then we get 0. And if we bring down the 0, we will have 0 here. And that's our answer. So 850 is the answer. Now what about this one? By looking at the divisor, we can see that there are 2 decimal points. So right off the bat, we could kind of see that we're gonna have to multiply this twice. So if we were to write out a division, we multiply 10 twice. And do the same here. And after we rewrite this, we have 9200 divided by 4. So we can complete a division by solving it. 4 times 2 is 8. Subtract, we get 1, bring down the 2. 4 times 3 is 12. So we get 0. Then we bring down the 0. So that will be 0. Bring down another 0 and another 0 up there. So our final answer is 2300. In this video, I'll be going over how to round decimals. In order to round decimals, you need to first look at the next decimal space to the right. If you have 4 or less, you would do nothing. 5 or more, you would raise it by 1. So let's look at the first example here. 4.58, and we're rounding to the 10th value. So the 10th value would be here. And so what we want to do is look at the next decimal space. In this case, we have 8, and 8 falls under 5 or more. So we need to raise it by 1. And by raising 1, it would become 4.6. And since we are rounding to the 10th, the value after 10th will no longer be there after. So 4.58 will become 4.6 after we round it to the 10th value. Now let's take a look at the second one. 76.652, and we're rounding to the 100th value. So in this case, the 100th value is here. And so we'll need to look at the next decimal space, which is 2. And since 2 falls under the 4 or less category, so we don't need to do anything. And the answer would simply be 76.65. So the 2 is no longer there, and the answer is 76.65 when rounding to the 100th value. Now the third example here, 8.2845, and we're rounding to the thousandth value. So here, this is 10th, 100th, thousandth. So we'll look at the next decimal space. This case is 5. And 5 falls under the 5 or more category, so we need to raise by 1. So we will rewrite it as 8.285. Now for the fourth one, 55.24, and we're rounding to the 10th value. In this case would be 2. Looking at 4, 4 is under 4 or less, so we don't do anything. And we will rewrite it as 55.2, and that would be the answer for that. So these 4 are examples of how you would round decimals. In this video, I'll be going over how to convert percents to decimals and decimals to percents. When you're converting percents to decimals, you want to divide the number by 100. Whereas decimals to percents, we want to multiply by 100. So from here, you can see the orange section is for percents to decimals, and green section is for decimals to percents. So the first example we have, we're converting 60% to decimal. So percent means every 100. So 60 divided by 100 equals 0.60. Another way that you can go about it is you could take the 60 and move 2 decimal spaces to the left and then place that 0. So either way, the answer will come out to 0.60. Now what about 122%? Although it's over 100%, we would write it the same way. 122 over 100. And that equals to 1.22. And if you try it by moving the decimal space 2 spaces to the left, you will have 1.22. So either way, you will have the same answer. Now for the second section, we're converting decimals to percents. And for these, we have to multiply by 100 to get to the percent. So for the third example, 0.65. What we want to do is take 0.65 times 100. And that equals 65. So that will be 65%. The other method is to take the decimal and move the decimal point 2 spaces to the right. And we'll end up with 65 as well. So either way, the answer is 65%. Now for the fourth example, 2.35. 2.35 multiplied by 100 equals 235. And using the other method, moving 2 decimal spaces to the right, we will also have 235. So the answer is 235%. So these are examples of how you would convert percents to decimals and decimals to percents. In this video, I'll be going over how to multiply decimals by powers of 10. Whenever we multiply a number by power of 10s, we're essentially looking at how many zeros there are from the 10. Then we will move the decimal point according to how many zeros there are. For the first example, we have 10.5 times by 10. Now the 10 that we see here has 1 0. So we're going to move a decimal point to the right, 1 space, like so. And so this will become 105. Now for the second example, we have a 7.2 times 10 square. Now 10 square means that this would be 100. And there's a total of 2 zeros. That means the 7.2 need to move 2 spaces to the right, like so. So the answer would be 720. For the third example, 14.72 times by 1000, there's a total of 3 zeros. So we will move 3 spaces to the right. Now there's 1 extra space, but there's no numbers there. So we'll fill in a 0 in place of that. And so the answer is 14,720. Now for the fourth example, we have 9.2 times 10 cubed. So 10 cubed will be 10 times 10 times 10. And so there's a total of 3 zeros. Then we take 9.2, move 3 spaces to the right. Place the 0. Then we have 9,200. And for the fifth example, we have a power of 4. So that's 4 zeros. 1, 2, 3, 4. And then we have 18.027. Moving 4 spaces to the right, and that would give us 180,270. 180,270. For the sixth example, we have 1, 2, 3, 4, 5. 5 spaces we need to move to the right. 1, 2, 3, 4, 5. Then we place the 0. Then we have 362,000 as the answer. For the seventh example, we have 2 zeros, and we have a 352. So the decimal point will be right behind it, and we need to move 2 spaces like so. Place the 0, then the answer is 35,200. And for the last example, we have 3 zeros. And so we can move 3 spaces to the right. And that will give us 670. So these 8 examples are how you will multiply decimals by powers of 10. In this video, I'll be going over ordering decimals. When ordering decimals, either from least to greatest or greatest to least, we need to first know which ones are the smallest number and which ones are the largest, and then place them in order. Below are 2 data sets. One, we want to sort them from least to greatest, and the other, we want to sort them from greatest to least. So for the first example, we have 2.45, 2.12, 2.54, 2.23, and 2.62. So first step is we're going to go ahead and write them out. Then what we want to do is find out which one's the smallest out of the 5 decimals. First, we want to compare the whole number here in the ones value, and since they're all 2, therefore we want to move on to the 10th value and compare to see which one's the smallest, second, third, fourth, and fifth. From the 10th value, 1 is the smallest, so this one will be first, the smallest number. Next, 2, so that will be second. Next, 4, that will be third. And then 5 will be fourth, and 6 will be fifth. Now that we know the smallest number to the greatest number, we can go ahead and write them out in order. So then we have 2.12, 2.23, 2.45, 2.54, and 2.62. So that would be the order that will go in from least to the greatest. Now for the second example, we also have 5 numbers in decimal, and we want to do the same thing where we write them out. We'll first compare the ones value. Since they're all 0, so we're going to compare the 10th value here from greatest to least. These 2 both are 8, so we'll go and compare the 100th value. And we can see 5 is greater than 2, so the first number will be 1, the second number will be second. Now we're going to look up the 10th value to see which one's next. And 6 would be next, but there's total 2 of them. And 64 is greater than 62, so the 0.64 would be third, and then 0.62 would be fourth. And lastly, 0.51. And now that we have them in order, we can go ahead and write them out. So that would be the order that it would be in. So these 2 examples are how you will order decimals, either from least to greatest or greatest to least. You want to first write out the numbers and compare them from ones value, then the 10th value, 100th value, and so on, and see which one's the smallest, which one's the greatest, and just place them in order and write out the sequence that they would be in order, and finally rewrite them in order accordingly. In this video, I'll be going over decimals to mixed numbers with simplifying. In order to convert decimals to mixed numbers, we need to first look at the last decimal place and determine the denominator. And then we will simplify after, if needed. For the first example, we have 6.4. So we'll first look at the last decimal place here, which is 0.4. This is the 10th value. So the denominator would be 10. And 4 would be the numerator. And since 6 is the whole number, so we would just place the 6 here. So that would be the mixed number. Then we can see 4 could be divided by 2 and 10 could divide by 2. So that would become 6 and 2/5. For the second example, we have 3.25. Now looking at the last decimal place, this is the hundredth. So for the hundredth value, we will have 100 on the bottom, and then we'll place the 25 as the numerator, and then the whole number will be 3. Then 25 and 100 can be simplified. Both can be divided by 25. So then this will be 3, the whole number, and then 1/4. And that will be the answer for example 2. Now for the third example, we have 15.425. Looking at the last decimal, we have in the thousands. And so the denominator would be 1000. And we want to put 425 as the numerator. Bring down the 15 as a whole number. Next, we're going to try to simplify 425 over 1000. Divide both by 25. 425 divided by 25 is 17. And 1000 divided by 25 is 40. And that would be the answer for example 3. Now for the final example, we have 6 as the last decimal place, and that would be 10,000th place. So we will put 10,000 as the denominator, and then 2,436 as the numerator. Now this is a big one, but we can see that both denominator and numerator can divide by 4. And so this will be 609 as the numerator, 2,500 as the denominator. And that will be the answer. So these 4 are examples of how you would convert decimals to mixed numbers with simplify. You want to first look at the last decimal place in order to determine what the denominator is going to be, and then you will simplify if needed. In this video, I'll be going over how to subtract decimals from whole numbers. In order to subtract decimals from whole numbers, we want to add placeholder zeros, then we want to line them up, and then subtract. Below are 2 examples, and we'll be going over each one. So for the first example, we have 8 minus 3.45. First step we want to do is we want to write out the 8. And since the 3.45 has 2 decimal places, so we also want to place 2 placeholder zeros after 8. So then that will become 8.00. Then we're taking 8.00 minus 3.45. From here, we can go ahead and handle the subtraction from here. So 0, we will need to borrow 1. This becomes 10. And 10 minus 5 is 5. Then this 0 has been borrowed 1. So it's currently at a -1, and we need to borrow 1 from the 8. So the 8 becomes 7, and the 0 becomes 9. Then we have 9 minus 4 equals 5. You will place the decimal point here. And 7 minus 3 is 4. So the answer for the first example is 4.55. The important part of this step is that we got to align the decimal places. So in this case, you can see the decimal point was here, and it aligned with the 3.45 here. So that we gotta make sure that the decimal point is always aligned. Otherwise, the answer wouldn't come out correctly. Now for the second example, we have 57 minus 9.3. So we can see that the 7 and 9 are both in the 1s position, and so we need to align the 7 and 9 together. So 57 and the 9 need to be right here. And since there is one decimal place, we need to place a 0 behind 57, so it'll be 57.0. And now you can see the decimal are aligned. Now we continue with the subtraction. So we'll borrow 1 from 7. This becomes 6, and this becomes 10. 10 minus 3 equals 7. 6 minus 9, we need to borrow 1 from the 5. So this becomes 4, and this becomes 16. So 16 minus 9 equals 7. We'll bring down the decimal point, and 4 will bring it down, and the answer is 47.7. So these two are examples of how you would subtract decimals from whole numbers. You would add placeholder zeros, line up the decimal point, and then subtract. In this video, I'll be going over place value with decimals. The place value of a number, depending on which position it is, it will increase by 10 as you move toward the left and decrease by 1/10 if you move toward the right. Here is an example. 5,232.523. In this example, the 2 here is the 1's value. The 3 here is the 10's value. And 2 is the 100's value. And the 5 here would be the thousands. So you can look at the value of 2 in the 1's position, because this number 2 means that there's 2 1's. So that's just the number 2. Now the 3 here is in the 10's position, and that means that it's 30. And the 2, since it's in the 100's position, is 200. And the 5 in the thousands position will equal 5,000. Now for the numbers behind the decimal, the 5 here is the 10th value because that's equivalent to 5/10. And the 2 here would be the 100's value, and the 3 would be the thousands value. And if we were to write out the value of each, the 10th value is 0.5, and the 2 in the 100th value is 0.02. And the 3 in the thousands position is 0.003. Now if you add everything together, we can see that the number 5 in the thousands position, and then we have 2, because 2 plus 0 is 2, and then 3, 2 plus 0 plus 0 plus 0 is 2. And then we will have the decimal point And then 5 plus 0 is 5. 2 plus 0 is 2. And 3 comes back down. And you see that this number on the very bottom, the 5,232.523, matches the number that we have from the example. Now let's look at an example of 800. When we have 800, if we were to move one space over, we would have 8,000. So when you move one space to the left, you're essentially multiplying by 10, as that makes the entire number of 800 8,000 instead. And if we move one more space to the left, we're multiplying by 10 again, and that would be 80,000. Now, if we have the number 8, and we're moving toward the right, that means that we are decreasing by 1/10, which means that we're multiplying 1/10, and that would become 0.8. So we're shifting the decimal point from here and moving the 8 from here over to here, and that becomes 0.8. Then if we want to do this again, we want to move one more space toward the right. That would mean moving this decimal point toward here, making it 0.08. And that means that we are multiplying 1/10 again to become 0.08. Therefore, when you move toward the right, you are essentially decreasing by 1/10, whereas when you are moving toward the left, you are increasing by multiplying by 10. Now here are some examples. For the first example, the 2 in the 100,000ths place is what of the value of 2 in the hundredths place? So our starting point is the 2 in the hundredths place. And we want to find out what's the relation between the hundreds to the 100,000ths. So we're moving toward the left. So that's 1, 2, 3. And that means that we are multiplying by 10 along the way 3 times. So 10 times 10 times 10 equals 1,000. So that means it's 1,000 times the value of 2 in the hundredths place. Now for the second example, the 5 in the 10,000ths place is what of the value of 5 in the hundredths place? So our starting point is 5 in the hundredths place, and we're moving toward the 5 in the 10,000ths place. So we'll be going 1 and 2. So that's times 10 here and times 10 here. So that becomes times 100. So the answer here is times 100. Now for the third example, the 3 in the tens position is what value of 3 in the thousands place? So our starting point in this case is 3, and we're moving toward the 3 in the tens place. So that's 1, 2. Now notice that we're heading toward the right rather than left, so we're multiplying by 1/10 as we move toward the right. And 1/10 times 1/10, that's 100. That means it's times 100. And for the fourth example, the 4 in the ones place is the value of 4 in the 100,000th place. So our position starts here and we're moving toward the 4 in the ones place. So that's 1, 2, 3, 4, 5. So that's 1, 2, 3, 4, and 5. And after multiplying that together, we will have times 1 over 100,000. So we will write it here times 1 over 100,000. And we got that because there's a total of 5 zeros. 1, 2, 3, 4, 5. So that is 1 and then 5 zeros. Like that. And that's in the denominator. In this video, I'll be going over decimals on the number line. There are 2 number lines below with 4 points. And what we want to know is the value of each point. For the first example here, we see that it's between 0.05 and 0.06. And there are exactly 10 equal parts between them. So to find out where this point lies, we need to first find out the value of each of these equal parts. Since there are 10 equal parts, that means that each one of them is 0.001. So that means that this point would be 0.05 plus 0.001. And that would mean it is 0.051. So if we want to find out the first orange point, we would then go 1, 2, 3, 4. So that's 4 spaces down, means that it would be 0.004 plus the 0.05, and that would give us 0.054. So therefore, we know the answer for the first point is 0.054. Now for the second point, the grid remains the same at 0.001, and let's see how many spaces from 0.06 is the second orange point. So we have 1, 2, 3, 4, 5, 6, 7. So that 7 means that this is 0.007 on top of 0.06. So we would then take 0.06 and add the 0.007, and that gives us 0.067. So that means that this point here is 0.067. Now for our second number line, we have an in tenth value. So we have 0.4, 0.5, and 0.6. And exactly the same, there's a total of 10 equal parts, and we want to know what each of them is. So between 0.4 and 0.5, that means that each of the equal part would be 0.01. So that's 0.01, 0.02, 0.03, 0.04, 0.05, and 0.06. So that means it's 0.06 from 0.4. So therefore, we need to take 0.4 and add 0.06. So we'll take 0.4 plus 0.06, and our answer is 0.46. And that would be this point here. Now for the second point, we have this as 0.01, so that's 1, 2, 3. So 0.03 from 0.5, so we'll add 0.5, add 0.03. and that becomes 0.53. And that's how we get the second point. In this video, I'll be going over how to write decimals in expanded form. Below are 2 examples, and we'll be going over each one. For the first example, we have 227.542. And below is the place value chart. And we're going to go ahead and fill in the place value chart. So we'll first look at the decimal. And we can see that 7 is right next to the decimal to the left. And 2 is right next by 7, and a 2 is next by the 2. So we will write 227 like this. And then we will write 5, which is right next by the decimal, and then 4, 2, like so. So now that we place the number in the place value chart, what we want to do is write them in the expanded form. So first, we'll look at the 2. This is in the hundreds value, so that means that it's 200. And 200 means that it's 2 times 100. In the expanded form, we can write them in 2 different ways. One is writing out the value, and the other one is multiplying by the value of where the number sits. So we'll do them at the same time. So next, we have the 2, and in the tens value, so that means that's 20, because 2 times 10 is 20. So that means this will be 2 times 10. And then the ones, there's 7 ones, so that means it's 7 times 1 is 7. So 7 times 1. Now for the tens value, we have 5, so that's 5 tenths. And we can write it like this, 5 times 1/10. Then we have the hundredth position, so that's 4 times 100th, which is 4/100. And we can write it expanded form, 4 times 100. And lastly, we have 2 in the thousands, so 2 times 1,000 is 2 1,000. And we will write it as 2 times 1 over 1,000. So by looking at this, we can see that the expanded form is written out like this. And then we have the parentheses format, which we write it out like this. So on an assignment or test, they would give you different examples of expanded form and expect you to understand how they got the expanded form from the number. Now let's go to the second example. So the second example is 52.65. So again, we'll go ahead and look at the decimal. 2 is next by the decimal. And then we have 5. 10 will be here, and 5 will be here. Okay. So now we're going to write the expanded form. 5 in the tens means that it's 5 times 10 is 50. Then we have 2 ones, means that it's 2 times 1 is 2. And we'll go ahead and write the parentheses format as well. So we have 5 times 10. Then we have 2 times 1. Then we have the tenth. There's 6 of them. So 6 times 1/10 is 6 tenths. So that would be 6 times 1/10. Next, it would be hundredth. So 5 times 100th means it becomes 5 100th. And the parentheses format would be 5 times 100. And now we have completed the expanded form in 2 different formats. This is one and this is the parentheses format. In this video, I'll be going over how to write decimals in written form. It is also referred to as decimals in word form. How you would read the decimals is how you would write it. And the sequence is the whole numbers first, if any, and then the decimals. So below is a chart with the whole number, decimal, then we have the tenth, the hundredth, and the thousandth value. And below are 4 examples, and we'll go over each one. For the first example, we have 42.26. So we're gonna go ahead and write it in the chart. So whole number in this case is 42. Then we have the 2 in the 10th value, and then the 6 in the 100th. So how would we write that in the written form? So if we were to read out this decimal, since there is value in whole number, we want to first read out the 42. So we will write it the same way as 42. And then we have the decimal point here. So decimal, we would say end. Then we will look at the decimals. In this case, it's 26. And since 6 is the last value, we want to read it as 2600. So then we will write 2600. So that's how you will read the first decimal. 42 and 2600. Now for the second example, we don't have any whole number, it's just 0. Then we have 95 at the end. How will we read this one? So let's go ahead and apply this number into the chart first. So we're going to write 0, decimal point, then 0, 9, 5. So since there's nothing in the whole number, we wouldn't read that. And there's nothing in the 10th value, so we don't need to read that either. Then we can see 95 here. And the last number of 5 is in the thousandth place. So we will read this as 95 thousandths. So that we would write this as 95 thousandths. And there you have it for the second example. Now for the third example, 2.35. Gonna apply in the chart. So whole number, if any, is 2. Then we have the point. Then we have 3, 5. So how will we read this? The whole number is 2. So we would say 2. So we write the word 2. The decimal, we would say end. Then we have 35 in the hundredth value, as 5 is in the hundredth. So we would say 2 and 35 hundredths. So it will be 2 and 35 hundredths. That's how you would read the third example. And for the last example, we have 0.175. And we'll go ahead and write it in the chart. Whole number is 0.175. So we have nothing for the whole number, so we won't read that. And the decimals would be 175, and the last number being in the thousands place. So we would just read this as 175,000. So it would be 175 thousands. And that would be how you would read for the fourth example. 175,000. In this video, I'll be going over how to compare decimals. There are two methods when it comes to comparing decimals. One method is by comparing by fractions, while the second method is comparing by value. We will use both methods for the two examples below. For the first example, we have 8.86 and 8.75. So first, we're going to put 8.86, and then we're going to place a box in between, and then we're going to put either greater than or less than after we find out which one's bigger. For the first method, where we're comparing by fractions, the first decimal is 8.86. So we have the number 8. That's the whole number. Second 8 on the 10th value, that's equivalent to 8 over 10. And the 6 in the 100th value is 6 over 100. And what we will do is we're going to find the common denominator. In this case, we have 110. So 100 being the biggest, we're going to use 100 as the denominator. So we're going to place 100 as the denominator. 8 times 100 is 800. And so if we have 800 over 100, in this case, that will become 8. So that's how we get 800 in the numerator. Now for the 8 over 10, since we are multiplying the 10 by 10 to get to 100, we need to do the same in the numerator. And that makes 8 times 10. So 8 times 10 is 80. Therefore, we would add 80. And lastly, we have 6 over 100. So since the denominator is already 100, so the 6 remains the same. It would just be 6 over 100. And after we add them together, we will have 886 over 100. That's an improper fraction. Now we're going to do the same for the 8.75. And that would be 8 plus, this will be 7 over 10 for the 10th value. And then we have 5, which is 5 over 100. And now we're going to go ahead and change that with the same denominator here, 100. So for the whole number of 8, we need to multiply by 100, just like before, and that becomes 800. For the second fraction, the denominator of 10 need to multiply by 10 to get to 100. And so we need to do the same in the numerator. So 7 times 10 is 70. So we plus by 70. And lastly, we have the denominator 100 and 5 as numerator. So we would just add 5. 5 over 100 remain the same. So we add up together. So after adding up together, we have 875 over 100. Now that we have the improper fraction set up for both fractions, and we see that the denominators are the same of 100, so we can compare the value of 886 and 875 and come to the conclusion that 886 is greater than 875. And so in this case, we will put greater than as the answer for the first one. Now let's try the second method, which is the value method. It is my preferred method as it's easier and requires less work. All you have to do is compare value by value based on the placement of the number. So if we look at the first example, we will have 8. Since they are exactly the same, we move on to the next number down, which is the 10th value of 8 here, and we compare that with the 10th value of the second number, which is 7. And if we compare these two, we can see that 8 is greater than 7. And just by that, we will know the first number is greater than the second number. So we will simply just put 886 greater than 8.75. As you can see, the second method is much faster and easier. But in some of the assignments or tests given to you, may ask you to compare decimal by fractions and making sure that you know both methods so that you can compare them accordingly. And for the second example, 263.415 and 263.402, we'll also compare them by both fraction method and value method. For the fraction method, we have 263.415. So what we're going to do is we're going to separate them like so. 263 plus 4 over 10 for the 10th value. 1 would be 1 over 100 plus 5 over 1000's value. Okay, now 1000 being the biggest, we're going to go ahead and convert all of the fractions and whole numbers to improper fraction with the denominator of 1000. So 263 will need to multiply by 1000. So it will become 263,000. For the second one of 4 over 10, we need to multiply that by 100 to get to 1000. And doing the same in the numerator, 4 times 100 makes it 400 in the numerator. And for the third fraction of 100, need to multiply by 10. And doing the same in the numerator, that gives us 10 on top. And for the last fraction, it's already at 1000 as the denominator, so we will leave 5 as it is. And after adding up all the numbers, we will have 263,415 over 1000. So that would be equivalent to the first number. As you can see from the first number, with the 1000 denominator, all you're really doing is moving 3 decimal points back. And that becomes 263,415 over 1000. So we can do the same with the second number, where we just move 3 decimal points, and that will become 263,402 over 1000. And after we compare the two numbers, we can see that the first number is greater. So the answer would be greater than. Now let's try the second method with value. So by comparing two numbers, 2 is in the hundreds position. Each of the number is 200. So they're the same. So we move on to the second number in the tens value, and both are 6. Since they're the same, we move on to the next number, which is the ones value, and 3 and 3. Again, they're the same, so we're going to move on to the next number, and that's in the 10th value of 4. And they're still the same, so we're moving on to the next one, which is the 100th value. And that one, the first one is 1, and the second one is 0, and 1 is greater than 0. And from this, we could write 260.415 is greater than 263.402. So as you can see, both methods will result with the same answer. But the value method is a lot easier and faster. If you are not being asked to do it by fraction method, I would strongly suggest that you go by the value method. In this video, I'll be going over equivalent decimals. When working with decimals, it is fundamental to know when decimals are equivalent in order to add, subtract, multiply, or divide properly. First, we need to know what the word equivalent means. Well, equivalent means equal. So the purpose of this lesson is comparing decimals and see if they are equivalent or not. And the tip of this lesson is the zeros to the right of the decimal do not change the value of the decimal. And we'll go over the 6 examples below and you'll understand what this means. For the first example, we have 0.70 and 0.7. When looking at these two numbers, you may think that they are not the same, as 70 and 7 are not the same. This is the case for whole numbers. However, it's not quite the same with decimals. For decimals, we can convert these two numbers to fractions. So 0.70 is equivalent to 70 over 100. Whereas 0.7, it is 7 over 10. So are these two the same? Let's look at the visualization of this. So first we have a 70 over 100. So let's look at this figure and assume this is 100. And in here, 70 of them is filled in. Then we have a 7 over 10. And this figure represents 10 units. And out of the 10 units, 7 of them were filled in. So now you can see the overall picture. 70 over 100 and 7 over 10, they are exactly the same. And another way you could look at it is if you take 70 over 100, divide by 10 in the numerator and denominator, you will get 7 over 10. And that's equivalent to 7 over 10 here. And vice versa, you could take 7 over 10, multiply the numerator by 10, and the denominator by 10, and you will also get 70 over 100. And isn't that the same as the 70 over 100 here? So now going back, we can see that 0.70 and 0.7 are equivalent. So this one is equivalent. So from the tip, it states that zeros to the right of the decimals do not change the value. So the zeros that we see here after the 7, although it looks like an additional number, but it does not change the value of the decimal. So therefore, 0.70 and 0.7 are exactly the same, and they are equivalent. Now let's look at example 2. We have two similar numbers, 0.70 and 0.07. Now are these two equivalent or not? So let's look at it in the same way, where we have 0.70 and that's equal to 70 over 100. And then we have 0.07 and this would be 7 over 100. The difference is that there's an extra 0 here, and that's toward the left side of the 7. Now if we want to look at it from the visual side, previously we have 70 over 100 already completed. Now we're gonna do 7 over 100. So having the same 100 unit, now we are only covering 7 out of 100, so it will be this little portion which will be equivalent to 7, and that would not be the same as the 70 over 100. Therefore, they are not the same. And so in this case, they are not the same. So the 0 toward the left of the decimal will change the value as it becomes smaller when you add a 0 to the left side. If you were to add a 0 toward the right of the decimal, they do not change the value. Now for the third example, we have 2.45 and 2.450. So 2.45 and 2.450. As you can see, the 0 was added toward the right, and each of the number are exactly the same, with the exception that the second number had an extra 0 toward the right. So they are equivalent. For number 4, we have 0.62 and 0.062. So go ahead and write it out at 0.62, 0.062. And right now you're probably guessing that they are not the same, as the 0 is toward the left of the 62, and that makes the value smaller, and so they are not the same. And for the fifth example, we have 2.305 and 2.350. So 2.305 and 2.350. As we compare each of the number 2 and 2 in the ones value, 3 and 3 in the 10th value, and the 100th value, we have 0 and 5. So right here we can already see that the first decimal is smaller than the second because the 100th value is 0, and that's smaller than the 5 on the second decimal. And therefore, it's not equivalent. For the sixth example, 0.743 and 0.74300. So 0.743, 0.74300. By looking at these two decimals, I'm sure you could already tell that the only difference are these two zeros. And when we have zeros to the right of the decimal, it does not change the value. So therefore, the two zeros behind will not change the value of 0.743, and so they are equivalent. And just on this note, even if we have add an infinity number of zeros, like so, you can go on and on and on. The value will remain the same, so it will still be 0.743. So we have compared 6 examples of decimals and determined which ones are equivalent and which ones are not. In this video, I'll be going over rounding decimals to the nearest whole number. And the tip of this lesson is that the nearest whole number would be the ones place. As ones place is the first position of the whole number, that would be where we are rounding. And whenever we are rounding anything, we are always looking at the number to the right of what you're rounding. Below are 6 examples, and we'll be going over each one. For the first example, 7.3. So the number that we want to round is 7. So we'll underline that. And the number that we look to will be the number to the right of that number. So 7 is the number that we're going to round, and we will round the 3 in the 10th place. So the rule for rounding is anything 4 or less, we will let it rest. Anything 5 or more, we raise the score. So you can memorize this in your head and use it when you are rounding decimals. So here we have 7.3. The number 3 is less than 4. So that means we will let it rest. So the 3 will become 0, and the 7 in the ones place will remain the same. So our answer is 7. For the second example, we have 2.626. So we are rounding the whole number, which is the ones place, and we look toward the right for the number that we're going to round. And here we have 6. So the rule of 5 or more, raise the score, applies to this one. And that means that we're going to raise 2 by 1, and that becomes 3. And everything behind will all become 0 because we've gone ahead and rounded up to 3. And the answer is 3. When we are rounding decimals to the nearest whole number, that means that we want our final answer to be the whole number only, without any decimals. So even though the answer is 3.000, we will convert it to 3 because the answer needs to be a whole number. For number 3, we have 5.52. Again, the ones place is 5. Look toward the right. 5 or more, raise the score. So we're going to go ahead and raise the 5 here to 6. And everything else will become 0. And that equals 6. For number 4, ones place is 0. And the number to the right is 8. And 8 is definitely above 5. So we're going to raise the score. This becomes 1. We raise it by 1. And then these become 0. And that becomes 1. And for the fifth example, we have 624.62. This number is bigger than previous examples, but the process remained the same. We're looking at the ones place and rounding the 1 in the 10th place. So 6 is above 5, so we're going to raise the score. So making this 625.00, and that equals 625. And for the final example, we have 25.145. And the ones value here is 5. And we'll look at the tens place. And since 1 is less than 4, so 4 or less, let it rest. So we're letting the 1 rest becomes 0. And we're not doing anything with the 5 because we're letting it rest. So the answer would be 25. So keep in mind that whenever you're rounding decimals, the rule is 4 or less, let it rest, 5 or more, raise the score, and everything behind that you rounded will turn into 0 after. So the last example of 25.145, notice that when we rounded the 1 and let it rest, it became 0, but everything behind it also became 0. So these 6 examples are how you will round decimals to the nearest whole number. In this video, I'll be going over exponents of decimals. Here's an example. 0.5 to the power of 4. The power of 4 here means that we have to multiply this 0.5 4 times. It would be equivalent to 0.5 times 0.5 times 0.5 times 0.5. And when we are calculating decimals like this, I like to take the numbers out and then place the decimals back after. So here we're going to take 5 out, 5 times 5 times 5 times 5, like so. So 5 times 5 is 25. Then we're going to times another 5. And 25 times 5, 125. Then times by 5. And we will have 625. And now we're going to go back and look at how many decimals do we need to place back. So here's 1, 2, 3, 4. So 4 decimal points. 625, I'll go ahead and rewrite it here. The decimal point starts at the end because this would be like 625.0. So we will move 4 spaces forward. 1, 2, 3, and 4. Now there's a gap here, so we're going to place a 0 in here. And since the decimal point ends right here, that means that there's a 0 in front of it. So we will have 0.0625 as the answer. Alright, let's try another one. 0.02 to the power of 3. So we're going to take 0.02, multiply it 3 times. Then I'm going to take out the number 2 from each and multiply them first. 2 times 2 is 4, and 4 times 2 is 8. Now we're going to look at how many decimal points we need to place back. So that's 1, 2, 1, 2, 1, 2. So the total is 6 decimal points that we need to place back. And here we have ended at 8. So this is 8.0, and we're going to move 6 spaces to the left. So that's 1, 2, 3, 4, 5, 6. Now there's a lot of gaps here. It's 1, 2, 3, 4, 5. So we're going to fill in with zeros. And we ended our decimal point here. So there has to be a 0 in front. And the answer we have is 0.000008. So 50 in front of 8. And that's our answer. Now for the third example, I have 0.3 to the power of 3. So again, multiplying them first 3 times due to the exponent. Take out the 3, so 3 times 3 times 3. So 3 times 3 is 9, 9 times 3 is 27. Now we just need to place back the decimal points. We have 1, 2, 3. So 3 decimal spaces. 1, 2, 3. And then we have this gap we need to fill in the 0. Decimals here. 0.027 is the answer. Hope by now everything is clear. I will go through one more example and then I will have a quiz example for you. So for the last example, I have 1.5 to the power of 2. Now this one's a bit different from previous as it has a number as a whole number rather than 0. But the process will remain the same. We'll go ahead and write it out. 1.5 times 1.5. Now in this case, we can take out 15. Leave the 1 decimal point for each. So 15 times 15 equal. And the answer is 225. Now we have 2 decimal spaces. 225. So we move 1, 2. And we leave the decimal point right behind the 2 here. So the answer is 2.25. In this video, I'll be going over estimate decimal multiplication. So let's jump right into the first example. 5.2 times 3.6. And what we're looking for is an estimate. So what we'll do is we're going to round it to the nearest whole number. So we'll take both numbers, 5.2, and we're going to round it to the nearest whole number. And when we round to the whole number, we look for the number to the right. This case is 2. And the rule of rounding, 4 or less, let it rest. So 2 is less than 4, so we will let it rest. It becomes 0, and we do nothing with the 5. So 5.2 will become 5. Now what about 3.6? 3.6, we're doing the same thing. Looking to the number at the right. 6 is 5 or more. Raise the score. So we're going to raise the 3 by 1 and make it 4. And 6 will become 0. As the number has been rounded, it becomes 0. So 3.6 in this case would be 4. So then we just take 5 times 4 equals 20. And our estimate answer would be 20. And we use this symbol for approximation. It's not exact. It just means that it's about 20. (5.2) we can imagine 5 containers which represents the 5 as a whole, and then we have another container which is about 2/10 full. So I'm gonna shade all of them to indicate that they are full. So that's what we have here, 5.2. And 3.6, we have 3 containers that are full. And for the 4th container, it's 6/10 full. As we are rounding, we can see 2/10 to be less than half. Half would be right around here. And of course, this is not drawn to scale, but this is 2/10. And since it's less than the 1/2, therefore we're letting it rest means we are taking it out completely. So this is gone, and we are left with 5. So this becomes 5. For the 3.6, and half of the container is right here. As you can see, 6/10 is 5 or higher, so we're gonna round up instead. So instead what we're doing is we're going to fill up the rest of the container and make this fourth hole. So now we have 4 containers that are full, and we have 5 containers that are full on top, and we multiply them together, and we get 20. This is a visual of how rounding works. You can imagine if container is half full, we're going to round up, and if container is less than half, then we're going to let it rest. In our case, we let the 6 container to rest, so we're left with 5. Now let's compare it to the actual answer. So if we take 5.2 and multiply by 3.6, our answer would have been 18.72. That would be the exact answer, and this is the approximate answer. So you can see we are actually very close, but by rounding and multiplying the numbers together, we're able to get the estimate value. Now let's try another one. In this case, 7.52 multiplied by 9.12. Now feel free to pause the video if you would like to work on this yourself before the answer is revealed. Simply play the video again when you are ready to see the answer. 7.52, rounding to the whole number, 5 or more, raise the score, raising 7 to 8. The rest turns to 0. So we have 8 as the first number. Then we have 9.12. 1 is 4 or less, let it rest, so we're not doing anything here, leaving it 9. So that would be 8 times 9. So the approximate value in this case is 72. Now what about the exact answer? If we multiply together, the actual answer is 68.58. So we can see that we're not too far off, and our approximate is close, so 72 would be a good estimate for this example. Now let's do one with slightly more decimal places. Now we can see that there are 3 decimal places for each of the number that we are multiplying, and what we are doing is still rounding to the nearest whole number. So even though we have 3 decimal places, we are still rounding it, to the whole number. So looking at the number to the right, that's what we're doing. Any number after 7, we don't look at. All we care about is the 7, because that's the number that's going to determine if we round up or do nothing. So 7 is 5 or more, raise the score. So we're going to raise 12 by 1 and make it 13. And rest of the number all becomes 0. And as a whole number, this will be 13. Now for the second number, as we look at the tens value, 3 is 4 or less, let it rest. So we do nothing with the 3. And everything after that becomes 0. So this will be 3. And then we just take 13 times 3. And that equals 39. And if we actually take the number 12.795 times by 3.329, our answer is 42.59. So our approximate is close to the exact. So we would approximate this as 39. So now you should be pretty familiar with how this works. And we'll have a quiz question right after this last example. So 9.14 times 2.92, rounding to the whole number. 1, we will let it rest. 9, we will raise the score. So take 9 times 3, 27. And so the approximate value is 27. And by multiplying the actual numbers of 9.14 and 2.92, we will get 26.69. So we are very close on this one. And 27 is a good estimate for this problem. Now we're going to do the quiz problem. And this is just one question and testing to make sure that you've mastered this lesson. So go ahead and pause the video and work on this, and I'll be back in about 10 seconds and work out the answer. Okay, I'm back. So for this problem, rounding it to the nearest whole number, 5 we would raise the score. This would become 8. And 4 we let it rest. So we have 8 times 4, which equals 32. So the estimate is 32. So if you've gotten 32 as the answer, great job, you've mastered this lesson. If not, please go back to the previous examples and review the area where you've made a mistake. And feel free to come back to this quiz problem again and try doing it again to make sure that you get it right. So the estimated decimal multiplication is to round each of the decimals to the nearest whole number. And make sure you know the rule of rounding as anything 4 or less, let it rest. Anything 5 or more, raise the score. In this video, I'll be going over estimate decimal division. So let's dive right into the first example. 31.2 divide by 5.22. And when we are estimating a decimal division, we want to first look at 5.22. We would round this number to the nearest whole number. So 5, we would look at the number to the right, and anything 4 or less, we let it rest. 5 or more, raise the score. 2, we will let it rest. So this becomes 0. So what we have here is 5. So rounding to the nearest whole number for the dividend, we will have 5. Now, how do we round the dividend here? We have 31.2. However, to get the actual whole number as the answer means that this number, the dividend, dividing by 5 will need to become a whole number because we are doing an estimate. So for 31.2, what number closest to 31.2 would it be when we divide by 5 would become a whole number? So in our mind, we could think of it like 30 divided by 5 is 6, or 35, because 35 divided by 5 would be 7. These are the two numbers that we can replace 31.2 with. And the closest one would be 30, because 31.2 is only 1.2 more than 30. 35 would be 3.8 more than 31.2. So in this case, we will put 30. So the number that we're looking for would be compatible numbers. And compatible numbers means that the dividend dividing by the divisor would become a whole number. So 30 divided by 5 is exactly 6. So the approximation is 6. And this symbol here means that it's an approximation. So the tip here is we want to round divisor first. Now let's try another one. 198.4 dividing by 9.52. Okay, so again, we're going to look at the divisor. 9.52, rounding to the nearest whole number. 9 will become 10, and 5 and 2 will turn to 0, so we just have a whole number of 10. And now we're going to look for the number closest for the dividend where we can get a whole number as the answer. So what number should we turn 198.4 to? So I can see 190 as a possible answer because we are dividing by 10. So I know 190 divided by 10 would be 19. Or we could go up to 200 and divide by 10 would be 20. Now which one is closest to 198.4? And just by looking at it, you can see 200 is only about 1.6 more than 198.4, whereas 190 would be 8.4 less than 198.4. So I would pick 200 in this case. And now we have compatible numbers of 200 divided by 10, and that equals 20. And so our approximation is 20. And hopefully this is clear to you. So looking at divisor of 4.8, 8 would be 5 or more, and when we raise the score, so we end with the divisor of 5. Now we have 42.52 as a dividend, and we want a number where it's closest that we can divide by 5 as compatible numbers. So we'll look at this and see that with the divisor of 5, we could use 40, because 40 divided by 5 is 8. And a number higher than 42.52 of 45, if we divide that by 5, it will become 9. So which of them is closer? For this example, I'm going to draw out a number line as we have 40 and 45, and we have 42.52 in between. Which one is closer? Here or here? So I can see if I was to go with 45, this distance would be 2.48 more. Whereas if I go with 40, it would be 2.52 less. So this one is very, very close. And sometimes when you have something very close, you could put both values in it. And so we can do 40 divided by 5, which equals 8. And then we have 45 divided by 5 equals 9. And the approximate value we would put 8 or 9, like so. If you put 8 or if you put 9, those are also acceptable. And now we're going to go through one more example before we get to the quiz problem. So I'll put this in the tip section. If compatible numbers are close, you may place more than one answer. So these are the two tips. And now we're going to get to the last example before the quiz problem. 11.62 divided by 3.12. So here we're going to round the divisor. This will become 3. Okay, and looking at this number, if we were to round the 11 to 12, we would have 12. So 12 divided by 3 is 4. So this could work. Now what about if we go down? So if you go down, it will be 12 minus 3, because of the divisor, will become 9. So this one is simple. We can tell that 12 is much closer to 11.62 than 9 would be to 11.62. So we're going to place 12 in here, and answer will be 4. And the approximate is 4. Now we're going to get to the quiz problem to see if you master this lesson. And here is the question. Okay, and feel free to pause the video while you work on this, and play the video when you are ready to see the answer. I will be back in about 10 seconds. Okay, I'm back. So hopefully you worked on the divisor, rounding to 7, and with the dividend, you have the choice of 49 or 42, and 49 is the closest, and the answer should be 7. So the approximation is 7. And if you've gotten 7 as the answer, great job, you've mastered this lesson. And if you didn't, please go back to the previous 4 examples and see the area where you've made the mistake. And you can always come back to this quiz problem again and try it again. So to estimate decimal divisions, we want to make sure that we round the divisor to the nearest whole number, and then try to find a compatible number in the dividend where we can divide by the divisor would become a whole number. And there are also possibility of 2 answers. If the dividend is really close, you can pick 2 dividends and get the answer one or the other. In this video, I'll be going over estimate decimal differences. Let's get right into the first example, 23.8 minus 15.4. When we are estimating the decimal differences, we are rounding each of the decimal to the nearest whole number. So to round to the nearest whole number means that it's to ones place, and we are looking at the number to the right. Since 8, under the rule of rounding, 5 or more raise the score. 8, we will raise 3 to 4. So basically we're adding 1 to 3, and then the 8 will become 0. And we bring the rest down, so the whole number is 24. Now what about 15.4? The number 4, we would let it rest because it's 4 or less, so that would be 0. But we do nothing with the 5 because we're letting it rest, and then we bring down the 1. So the second whole number is 15. And then we're taking 24 minus 15, then our answer is 9. So our approximation is 9. That's the answer. And the sign that we're using here is approximation. It's not the exact answer, but it's just an approximate. Now, if we actually take 23.8 minus 15.4, inputting that in a calculator, the actual answer is 8.4. So we can see that 9 and 8.4 is very close, but the purpose of this exercise is to get the approximate and not the actual answer. So if you put 8.4, that would have been wrong. We actually want the estimate answer, which in this case would be 9. Now let's look at another example. 119.75 minus 19.99. So the number is a little bigger this time, but the process remained the same. We're rounding to the nearest whole number. looking at the number nearby, 119, we would need to add 1 because we're rounding up 1. So rounding up will make this number 120. So that's the first whole number. Second one, 19, we look at the 9 in the tens value, and it's 5 or more, raise the score. So we're raising 19 by 1, becomes 20. So then 120 minus 20, 100. And so our approximate value is 100 even. And for our next example, 84.62 minus 13.23. Looking at the whole number and rounding, 6 we will round up, 5 or more, raise the score. 2, 4 or less, ladder rest, so we do nothing with the 3. 85 minus 13, the answer is 72. And the actual answer, if we input it in the calculator, would have been 71.39. So you can see the numbers are actually very close. So our answer is 72. And we will work on one more example before we get to the quiz problem. And here is the example, 42.98 minus 22.42. By now you should be pretty clear on what to do with this. So feel free to pause the video, work on it, and then play a video when you are ready to see the answer. So 42.98, rounding to the whole number, we have 43. As we will round 9 up. 22.4, 4, we will let it rest, so 22.00. So then we will end with 43 minus 22, and that gives us 21 as the answer. So approximate value is 21. The actual answer, if we input in the calculator, 20.56. So again, it's very close. So now we're going to get to the quiz problem. And the purpose of the quiz is to make sure that you've mastered this lesson. And here is the question. 15.52 minus 8.91. Now feel free to pause the video, work on this quiz problem, and when you have the answer, play the video and see the answer in action. Okay, I'm back. So hopefully you try to round first, and 5 we will round up, become 16. 9 we also round up to 9. So we end up with 16 minus 9 equals 7. So the approximate value is 7. And if you got 7 as the answer, great job. You've mastered this lesson. And if you didn't, please go back to the previous 4 examples and see the area where you've made a mistake. And feel free to come back to this quiz problem again and redo it and see if you get it right the next time. So estimate decimal differences means that you want to round the decimal to the nearest whole number and then subtract. And make sure you know the rule of rounding, 4 or less, let it rest, 5 or more, raise the score. In this video, I'll be going over estimated decimal sums. Here's an example. 24.5 plus 9.1. When we are estimating decimal sums, we want to round both decimals to the nearest whole number. And the sign that we use here is an approximation. It's not an equal sign because equal sign would be the exact answer, whereas this sign means that it's approximate. So the purpose of the exercise is to find the approximate whole number for the two decimals. So for first number, 4, we want to look to the number on the right. 5 or more, raise the score. So we're raising the 4 by 1, it becomes 5. As the 5 rounded up, it becomes 0. And we would bring down the 2. So the whole number for the first decimal is 25. For the second decimal, we are looking at 9 and for the number to the right. In this case, 1. 4 or less, let it rest. So 1 would turn to 0 and we would do nothing with the 9 as we're letting it rest. So now we have 25 plus 9. And 25 plus 9 is 34. So our approximation is 34. Now, if we actually take 24.5 plus 9.1, the answer we have is 33.6. That's an exact answer, whereas our approximate is 34. So you can see that it's actually very close, only off by about 0.4. Now for the second example, we have 125.62 plus 22.43. Now if you are pretty familiar with this, you can go ahead and pause the video, work on the problem, and then play to see the answer. So we're rounding 5 or more, raise the score. 4 or less, let it rest. So we're not doing anything here, we're letting it rest. 126 plus 22. And what we end up with is 148. And if we actually input this in a calculator, we would get 148.05. So this one is really close. We're basically just 0.05 away from the actual answer. But again, what we're looking for is the estimate. So the answer would be 148. Let's try this one. 22.62 plus 13.25. Rounding to the whole number. This will become 23 as we are rounding up. 2, we will let it rest. 23 plus 13 is 36. So 36 is our estimate for this one. The actual answer was 35.87. So this one we're also very close, only about 0.13 away from the actual answer. Now we're going to work on one last example before we get to the quiz problem. 34.55 plus 26.25. Here, also rounding. 5, we would round up. And 2, we will let it rest. So we end with 35 plus 26. And that equals 61. So our approximate is 61. And if we actually calculate the real answer is 60.8. So we're 0.2 away in this case. And now we're getting to the quiz problem. For the quiz problem, I don't need the actual answer, just the approximate that you get. So this quiz problem is 56.45 plus 17.58. And I need the approximate answer. So feel free to pause the video, work on this, and play the video when you are ready to see the answer, and I'll be back in about 10 seconds. Okay, I'm back. So hopefully you rounded the numbers and you left this as it is. You let it rest. due to the 4, and you round it up because of the 5, and you end with 56 plus 18, and you've gotten the answer of 74. And if you've gotten 74 as the answer, great job, you've mastered this lesson. If not, feel free to go back to the previous examples and see where you made the mistake. So getting the estimated decimal sums means that you are rounding to the nearest whole number, and using the rounding rule of 4 or less, let it rest, 5 or more, raise the score. Then add the two numbers together to get the estimated sum. Remember, we're not trying to get the actual answer, but the approximate, which is why we use the approximate sign in place of the equal sign.